Hello, everyone. Good evening. Good morning to everyone who is joining from different geographies of the world. Let me introduce myself. I'm Sindhu Priya, working as Senior Manager for Marketing and Alliances in Amdis Technologies. Happy to welcome our speakers. Let me start with Mukesh Kumar, our product architect.
Good morning, everyone.
Let Hello, Mukesh.
Hi.
It's great having you today. So Mukesh is our product architect who led the Databricks implementation in our own flagship product, CloudCADI. And now let me welcome Jeffrey. Hello, Jeffrey. Welcome. All right. So we have Mr. Madhu Kumar, our founder and CEO. Welcome to the discussion, Madhu sir.
You should unmute my mic. Oh, thank you. Thank you, Sindhu. You unmuted it. Very good. Thanks all. Look forward to have a good chat today.
Great. So, listeners, last year we hosted a 5-month webinar series dedicated to cloud FinOps, and the response was truly incredible. We saw consistent engagement with nearly 100 registrants joining us for almost every session. So, your support and enthusiasm are what encouraged us to return this year with a new, more focused topic: Databricks Unity Catalog, Smart Governance, smart optimization and strong data governance. So we chose this theme because the organization, as they scale their data workloads, the need for a unified, secure, and efficient governance framework becomes absolutely essential. At the same time, the other areas, the teams are feeling increased pressure to optimize the performance and managing the costs and finding the right balance. So, in today's session, our experts will walk you through how Unity Catalog can bring structure, visibility, and control to your data landscape. And by the end of this webinar, listeners, you will leave with all practical insights you can start applying right away. So before getting into the session, if you have any queries, please do drop us at the comment section. Our experts will address them at the end. With that said, let's look at the agenda for today's topic. So, our experts will start with data workload optimization fundamentals, followed by the deployment architecture of Databricks and Unity Catalog basics. Then they'll dive into the Databricks optimization challenges that prevails in the industry, followed by the best practices to overcome all of them. We'll also discuss about the benefits of the intelligent optimization, implementing the best practices. Then we'll also show a quick demo on what we do, our flagship product CloudCADI does for Databricks optimization. So as I said, the end will be the question and answer session. Saying that, let me welcome our DevSecOps engineer, Jeffrey Jebaston, to start. And before getting into that, Madhu, why don't we hear a few words about this topic and what would you like to say for the listeners?
Yeah, well, thanks, Sindhu. I think for the last, I would say, close to 6 months or maybe 1 year, the entire FinOps optimization has been heavily focused on using data workloads. Can AI work on it? Generative algorithms, how do they work on it? And there is a plethora of investments by platforms like Databricks. Today we are going to talk about Databricks, but there are platforms like Snowflake and other data platforms are investing a lot of new tools for end customers who are listening in. But I thought it will be a great idea for us to show how CloudCADI weaves in all the needs for customers in terms of running, whether it is on the platform's own cloud or running the platform on hyperscaler cloud. So this has enormous nuances for each customers to look at. So That way, we will, when we look at the evolution of data workloads briefly, followed by how are we optimizing the data workload in terms of cost. But I like the way our team worded it, the smart optimization, because not everything is cost alone. You look at catalogs, you look at the way you're running workloads, but you need to be very, very cognizant of where your data resides. Each geography is putting in enormous controls on cross-border data security, geography resilience, and on anything related to data residing outside your purview of geography. So, with all those constraints, you need to look at your workload optimizations, and you have to be financially prudent. So, to do that, you need products very like CloudCADI eventually to do it within your environment. That's why I thought it will be a great session, and I would like to hear from Mukesh as well as Jeffrey. And thank you, Sindhu. I'm sure it will be a very exciting session. Okay.
Thank you, Madhu. Let's hear it from Jeffrey. Jeffrey, please begin the session. I'm sharing the presentation for you.
Thank you, sir. Thank you. Um, okay, so I'm very happy to be a part of this webinar, and I think we can get right ahead into Databricks. So before starting this, I would like to go on a pre-Databricks era, right? So we know that the ML workflows, they have various steps through the way. And how were they actually done? They actually had different services. So I would mind by going through them service by service and the process, right? So it's data for data warehouse we had Teradata, and for Oracle X data also we had for that. And then we had ETL. For ETL, we had Informatica and Talent. And for data lakes, we had Hadoop, distributed file systems as well as on-prem systems. So we could actually import them there too. And then for the compute processing, we mostly Apache Spark. We use them. And even today, they provide the compute resources needed for Databricks, right? And then for scheduling, monitoring, and managing, we actually use Apache Airflows. And then for the jobs running, right, we actually used simple, unique cron types, right? So this was the period, pre-era period of Databricks. And post-era, like after 2013, what happened was Databricks brought all of these under an umbrella, right? So the umbrella was big enough to bring all of them, all of the services together, and to also unite versions so they don't have version clashes, and then set up security measures, which we will be actually seeing in the near future, right? So first of all, we need to understand the basics of Databricks. So as we know, it's a big AI ML platform, right? And which is mostly scaled by Apache Spark, as we know it. And these machines are actually deployed over a new cloud environment, where we'll see more about it in the deployment architecture as well. Now, who uses this product actually? This product is actually used by many people, including AI engineers, ML engineers, as well as data scientists, as well as data engineers, and data analysts as well, and many more. Right. I think we can move to the next slide. Right. Thank you, Sundar. And so for here, we actually start seeing the deployment architecture, right? So there are actually two planes in the deployment architecture, right? So one is the control plane and another is the compute plane. So the control plane actually basically has the web application, gives us the compute orchestrations, all details about the compute. And then we have the Unity catalog for security as well as a data governance. And then we have the notebooks for the codes, right? So next of all, we'll come. to the serverless a little after this. But your basic compute is actually going to stay in the cloud account that you've subscribed with, as well as your resources. When you're deploying it here, it will automatically deploy into the cloud, right? And so, uh, as it goes, serverless compute actually is deployed inside Databricks itself. It actually happens in the control plane layer itself. All right. So here we need to actually cut costs. To actually cut costs, we are going to see a few options of how we can do it, right? So one good idea is actually enforcing metadata and tagging standards. So let's just take it for an example that five teams are actually working, and it's better to go ahead with tagging and all of the resources that are deployed as well as taken into account, they are deployed with the tags. And as well as the tags can be the name of the TLs or the directors that who work through it. All of them can be pulled in, right? And the next one is mostly we'll also apply workload lifecycle controls, which actually includes TTLs, query timeouts, as well as storage lifecycle policies. And then we actually establish platform guardrails as well. For this, we have options for workload isolation, resource quotas, and permission boundaries as well, right? And as a final thought, we have actually system tables, which actually has all of your monitoring data. So the one of the upsides of this, the advantages of this is that the data is automatically taken. The monitoring data is automatically taken. So you can obviously use data analysts or gather a team's data and strategically make budgets for them so that those teams can work in budgets, right? So it's actually a big thing. The next point of the view is that I would like to move a little towards security, right? So there was something called as Unity Catalog, right? It was brought around, it was introduced in around 2021, implemented in 2023, right? And going further into it, it was actually designed. So what I have is a basic mind map, not the exact thing, but mind map works very well, right? So we have some layers. So these are again divided into two more layers. One is the core layers, and the other one is the ecosystem layers. So the first layer is going to be the identity layer. This layer is through which the APIs cross the accounts when given to AWS, GCP, or Azure. These accounts are actually managed in the identity layer, right? Next one is the access control layer. So this layer is actually given to workspaces, clusters, and notebooks. Who can access them? What kind of access they have? And then permission. This is like for specific people, what can they do inside the workspace? That is permissions. And then for Unity Catalog, yeah, it's a layer again, even in that. So there is data governance as well as data lineage as well as data audits. So Unity Catalog takes care of all of that. So the next layer is the possible data layer, as everybody knows. So actually, data engineers would probably know the medallion architecture, right? So they take up raw data, ingest it into the bronze storage, and then which moves cleaned up into the silver, and then the cleaned up silver is then merged, and more effective data and or for effective workloads are taken from the golden storage. So it's like a three-part access. So you have individual access to these data versionings via transaction logs. Okay, and each of these data layers are supported by the data lineage, which will also be recorded. This is the metadata, um, which will also be stored in the system tables, right? So coming to the next point, actually, uh, I would like to go to the next slide, so that we don't. Yeah. And now for Databricks optimization challenges, I would like to call upon my senior, Mr. Mukesh, who is much more experienced in this field. He would give extensive knowledge for us. Thank you. Thank you so much.
Thank you, Jeffrey. Thank you for your introduction. So let's talk about Databricks optimization challenges. So the first thing that comes into mind on optimization is figuring out whether we are over provisioning the server or under provisioning the server. So this is the first step everybody does in optimization. The problem with this technique in Databricks is that workloads are completely dynamic. Most of the workload run as job compute, which are mostly used for scheduled compute. The demand comes at a certain scheduled time. So, what is possible? What can we optimize or what can we manually tune in Databricks? So there are a couple of things we can manually tune. The first thing, what we usually figure out is whether the cluster is idle or it is getting used at some point. So that is the first thing everybody does, figuring out what is the ideal, whether the cluster is idle or not. Then in the life cycle of a cluster, if you look at it, when the creation of the cluster, we start doing small tunings, choosing runtime updates, proper runtime updates, and the instances we choose are specifically workload based instances. When we are choosing for dev or test development, so we specifically choose for a spot instance. So these small tuning brings in some sort of a cost optimization or well utilized status in missions. Uh, so these are the things. There comes a bit more smart optimization where once the entire uh, Databricks environment is set up and it's running for a couple of months, then we can slowly start looking at few smart optimizations we can do. Sindhu, can you move to the next slide? Yeah. So, so the majority of the Databricks usage goes into running scheduled jobs, basically. So the first thing what we have to look at is grouping of jobs. So this will basically reduce the cluster startup time and cluster deprovisioning time. So that is the first thing we have to look at in a well set up database environment. The second is identifying inefficient jobs. In our case, we add 20 to 20 percentage of the job that contributes to 80 percentage of the cost. That is because that is due to bad code, uh, choosing improper instance, in the sense of choosing a large cluster, or in another case, it's choosing very small cluster for big compute needed places. So these are the major things that makes a job very inefficient. One more instance, one more case is setting up retries at a very short period of time. Retry should happen at least 10 minutes gap for two times, or if it fails for the two time, it should extend it to a longer period. Then after it should retry. If the retry is very frequently running, it again brings up the inefficiency of the job and increases the cost in turn. Okay, so the third optimization is very important, which is updating auto scaling configuration periodically. In one of the case, the clusters in like this year, uh, the clusters optimization, auto scaling cluster optimization, we were in the start of Jan, we have to configure a cluster for 8 to 16 node size. Later, the requirement got reduced and it got unnoticed, and the current auto scaling reconfiguration we have set up is for 8 nodes to 4 nodes. So these kind of auto scaling configuration we have to update it periodically, and this can be detected based on cluster usage patterns. Other three things, other three optimizations. One is if the code is written in complete in SQL query, the long running SQL queries are quickly can increase the cost of the SQL warehouse. These long running SQL queries are because of bad joins or bad indexing. There should be a system set up to terminate these things. Databricks already gives us a query timeout status where we can set up a query timeout. If it is longer than that timeout limit, it automatically terminates. So this is one of the smart optimization. And last thing is we have to detect unusual spending patterns. That Databricks already gives us a very good account usage dashboard. We have to always monitor, set up alerts on certain tags and metadata to quickly figure out the unusual spending patterns. Next slide, Sindhu. So by continuously optimizing these uh, above optimizations, applying these continuous optimizations, so we were able to reduce the cost very drastically. We achieved a 30 to 40% reduction in the compute cost, and we also have set up automated identification for underutilized clusters, inefficient jobs, and long-running queries. So these are the things that can be achieved. So, Sindhu, next slide. So, apart from this, we internally also in CloudCADI, we have set up few more use cases we like to demo with you in this stage. Okay. So the screen right now you see is this is the dashboard pane which CloudCADI gives the end user for monitoring and analyzing the usage data. The first chart talks about the compute level spend for each and every workspaces. All-purpose compute, job compute, SQL compute, all different compute that are being used under these workspaces. This is the first chart talks about. The second one is a very important chart. So this is the cost distribution of the platforms. The top the dark blue is the Databricks spend, the amount which we pay for Databricks, and the below is the amount we spend for the AWS environment. The next chart is cost per APC, cost per all-purpose compute, and top 10 jobs that runs in your environment, and cost per warehouse. So this dashboard gives a quick view on the entire dashboard, entire Databricks environment, different multiple workspaces, and in a certain space of time. And the recommendation which I was talking about for the Databricks is there are few complicated recommendation like CloudCADI helps to solve here is. So we touch upon two things, two service that Databricks provides. One is job compute, one is all-purpose compute. So in these two categories, we give three different types of recommendations. The first job compute recommendation as this specific cluster, the December 17 complex job 1 cluster, is a worker type of M4 large. It runs in a 2 worker instance and its utilization is around 4%. So our internal stimulation algorithm runs to multiple possible scenarios, looks at the spark logs, looks at the performance logs, and it gives the recommendation of single worker. Similar for this job compute, we show multiple different recommendations. For let's say if three to four different clusters runs in your environment, all the 3 to 4 clusters will run across all these recommendations and will come upon one of the specific category. So in this recommendation, this is entirely different cluster, December 17 migration cluster. It is using R5D 24x large mission. Its utilization is very low. So this mission is basically a incorrectly picked instance. So the CloudCADI detects it and it gives a recommended worker size for this. And in turn, it also projects what will be the utilization for it. Similar to this above scenario, we do the same type of recommendation for all purpose clusters as well. And finally, we also monitor for all the different issues that happen in the cluster. In one case, we look for data spill and data skew. For every jobs that run, we continuously monitor the Spark logs, and we look at every executor's usage pattern. We figure out data spill and data skew, and we calculate if because of that how much time it is getting spent, what is the delay, and how much cost it is because of the delay, how much cost it is taking. So all of these things calculated, and also we point out which specific place, which specific code, which specific line, and the notebook path for that issue. So these are some complex recommendation use case CloudCADI try to solve. And CloudCADI is also a cloud agnostic solution where we also look at different services in across AWS, Azure, GCP to optimize. One of the use cases Databricks we currently look at in this webinar. Thank you for your time. Sindhu, can you move to the next slide?
Thank you, Mukesh. Thank you for sharing us what CloudCADI can do for Databricks optimization and walking us through all the optimization challenges and the suggested best practices. So with that said, so now that we have completed the demo, we are moving to the questions. So if you have any questions, listeners, you can please post it over the comment box. And we have one comment from Mr. Seshadri asking for a recorded version of the session. Mr. Seshadri, the recorded version will be on LinkedIn forever on our Ramdis Technologies page. We would love to send that to you over mail as well. Thank you for doing that. Thank you for mentioning that. So with that said, I think we don't have any questions so far. It's been around 30 minutes since we started. So why don't we move on to our profile? We want to say thank you, and why don't we hear it from our founder and CEO before we close on what is, I would like to hear more about the Databricks current challenges beyond what our expert shared today, Madhu, and also your tips based on your observation at the front end from the different customers you meet.
Okay, thank you, Sindhu. I know there is only hardly 2 or 3 minutes left for the day, but otherwise, Mukesh and Jeffrey, great presentation. You guys walked through what are the challenges. And Sindhu, for the audience, when I deal with clients, when we talk to them, the use cases are generally, when you run data workloads, these are all tools like Databricks are brilliantly orchestrating the open table formats. So that itself is a first question. How do we run it in such a way that, we take care of risk governance compliance? In addition to that, for performances, an element of oversizing comes in, and that's quite natural. You need to keep the end customers happy in any enterprise. So the needs of the data scientists, the needs of the end customers, the needs of the query, the element of slight over provisioning will start, the workloads will run. But I always walk in and talk about continuous way of looking at your entire spend, manage it thoroughly so that you spend the right money in the right place. Because Databricks per se, they do have your own Databricks on public cloud platforms like what Mukesh said, talking about Azure, AWS, or Google, but they also have serverless components. So there is a mature decision you need to take. So that makes the observability very important. That takes the entire Unity catalog and the flow of data very important. So an enterprise has to look at your cost, performance, and utilization of all assets very specifically on the Databricks side, as well as the data pipelines, and then make informed decisions. And that's where products like us come in. The uniqueness of CloudCADI is that the product runs within the private cloud environment of the customers. We are not SaaS because there is an enormous amount of money you spend in terms of exporting logs and everything for SaaS products. This is not a SaaS model. It's running within the customers. It's a containerized workload. CloudCADI can run within the environment. Technically, we are solving for areas in terms of healthcare as well as some workloads in financial services, where the purpose is to find the optimal way of running the workloads, whether it is on high-end servers or like the way you looked at the use cases Mukesh was talking. And I'm sure it will be a very useful session for the audience. And as you said, if they have any question, they can reach out to you or to our experts or to us through website or through the platforms. Thank you, Sindhu.
Thank you, Madhu, for your notes. So, listeners, we are leaving. So, I'm just leaving the contact credential slide for a couple of minutes for you to take note of. If you have any questions on the topic, do write to us at info@amdisglobal.com, or if you want to look at our product, a complete demo of it, what we can do, even beyond Databricks, if you would like to have a complete demo of the product, please write to us to CloudCADI@amdisglobal.com. You can also call us to the numbers mentioned on the slide. These are our offerings and company overview and all. We would love to brief you over the call if we wish to have more details. So with that said, we are always active on LinkedIn. Do write to us on LinkedIn. Also, with that said, we are about to close the session. So far, we are good to go with our, the questions. Yes. So we are good to close the session. Thank you, Mukesh, Jeffrey, for being with us throughout the session and walking us through Databricks workload optimization with the power of Unity Catalog. Thank you. We'll come up with another interesting webinar session with our experts very soon. Wait for it and follow us on LinkedIn for all the recent episode notifications. Thank you.
Thank you.